Good day, everyone. So last video we talked about simple and compound interest. Now this time we're going to tackle simple and general annuities. But before that, I want you to recall the compound interest, since understanding the compound interest will help us to grasp the concepts of annuities. So let's start with an example. You invested an amount of 10,000 pesos to an account with 10% interest compounded quarterly for 1 year. What is the compounded amount at the end of the year? So let's try to solve this. Okay, so since the problem is about compounding quarterly, so we have 4 periods here. So for the first 3 months, we have here the first quarter, and for the second quarter is we have the next 3 months, and we have third quarter, and the last period is the fourth quarter. So since the principal there is 20,000, so we have there as the starting amount is 20,000. So for the interest, since the interest is 10% compounded quarterly, so we divide 10% with 4, since the 10% there refers to the interest rate per year, and we still have to find the quarterly rate. So to find the quarterly rate is we divide 10% with 4, and that would be 0.025. So the 0.025 there is the quarterly rate, or the rate per period. So the quarterly rate is we use this to multiply with the principal amount for the amount for the first quarter, that would be 20,000. Alright, so 20,000 times 0.025 would give us an amount of 500 pesos. So the 500 pesos there is the interest earned for the first period. So after that, we add the 500 to the 20,000, and we have a new amount which is 20,500. So this 20,500 will be the new principal for the second quarter. So also in another way to get a 20,500 aside of multiplying like this is we just simply multiply 20,000 by 1.025. So you can see there that I just simply add 1 with 0.025. It's because the 1 there represents that we already add the principal or amount of 20,000 after we multiply the 20,000 with the quarterly rate, which is 0.025. Okay, so now let's have the new amount or the new principal 20,500. We multiply it with 1.025, and we multiply first the 20,500 with the quarterly rate. That would give us an amount of 512.5 pesos. So this is the interest earned for the second period or the second quarter. Alright, so we add this to the 20,500 since this is already the new principal. So we have the new amount 21,012.5 pesos. So this amount will be the new principal for the third quarter. So we multiply again with times 1.025, and the answer for that would be the new amount or the new principal for the fourth quarter. So first, let's find the interest earned for the third quarter by multiplying 21,012.5 with the quarterly rate. So with that, we get 525.31. So this is the interest earned for the third quarter. Okay, so we add this here with the new principal, we get 21,537.81. So this is also the result when we multiply this. So 21,012.5 times 1.025. Okay, so next, this is a new principal, and we multiply it with 1.025, and that gives us an amount of 22,076.26, wherein the interest we earned for the fourth quarter is 538.45. Alright, so this amount here is the final amount at the end of your term, which we called the future value. So the future value at the end of the term, wherein you have a principal of 20,000 and with an interest of 10% compounded quarterly is 22,076.26 pesos. Okay, so if we use the formula that we have in the previous video, we have here F, which is the future value equals P times 1 plus J over M times to the power of TM. Alright, so we just simply substitute there it to the formula. That would be 20,000 times 1 plus 0.10 over 4 to the power of 4. So that would give us a result of 22,076.26 pesos. So still we have the same result here if we use this way or if we use this formula. Okay, so that's how the compound interest works, and it's very important to understand the concepts of compound interest because this will be used to understand the next topic, which is simple and general annuities. Okay. So a sequence of equal payments made regularly or periodically is called annuities, and annuities are observed mostly on investments, insurance, retirement plans, and also in mortgage or um, other types of loans. So, and what it makes an annuity is because of its fixed payment made every period. So, as you can see here in the illustration, from the origin date to the maturity date, we have this, the length of the stew is what we call the term, or this is the whole transaction period. So the term there is consists of the different periods where the periods have equal length of time, and periods can be monthly, quarterly, semi-annually, or annually. Now, for the first period here, this is the first payment interval. So when you say payment interval, this is the length of time given before the payment due. So this is your payment due, and we have here the R. So R there represents the periodic payment. So the periodic payment is the fixed amount that you pay every period. So for the second period here, we have the R again, and the amount that you pay here is the same amount that you paid for the first period. And it goes on up until to the last payment before your term ends. Now, all this here is, if all this process that you see here is what we call the annuities, because the R here are equal payments or equal amounts, and if the sequence of these equal amounts with interest on it is what we call the annuities. So there are different types of annuity if we categorize it based on the payment interval and interest period and based on time of payments. So if we have an annuity that is based on payment interval and interest period, we have simple and general annuity. So it's a simple annuity if the payment interval is the same with the interest period. So for example is you have an investment where you pay every month and the interest is 10% compounded monthly. So that is the payment interval is the same with the interest period, which is monthly, so we can say that it is a simple annuity. Now, if it is not, that is the payment interval is different with the interest period, we can say that this is a general annuity. So for example is your payment is made every month, that is monthly, and the interest is compounded annually. So it means that the payment interval is different with the interest period, so we can say that it is a general annuity. Alright, so if the annuity is based on time of payments, we have ordinary and annuity due. So that would be if the payment is made at the end of the payment interval. For example, your payment interval is every 3 months, so that would be quarterly, and at the end. So it means that the ordinary annuity is the payment at the end of the quarter. So it's at the end of the quarter, we can say that this is an ordinary annuity. All right. So if it is not, that is, if the payment is at the beginning of the payment interval, for example, is it's the beginning of the first quarter or it's the beginning of the quarter, then it means that this is an annuity due. Alright, so these are the types of the annuity, and also there are other types of annuity, but I choose to focus on these four since it's one of the most common and basic types of the annuity. So now let's go with the examples, determine whether the given situations represents simple annuity or general annuity. First, payments are made at the end of each month for a loan with 2% interest compounded monthly. Now let's identify the payment interval. So the payment interval here is month by month since the payment is made every end of the month, and the interest period is monthly also. So since they are the same, the payment interval is the same with the interest period, we can say that it's a simple annuity. So next, Dave deposits an amount of 10,000 pesos at the end of every 6 months to an account that earns 7% interest compounded annually. So the payment interval here is every 6 months, which means that it is semi-annually, and the interest period is compounded annually, so which is annually, right? So we can say the interval payment is different with the interest period. So we can say that it is a general annuity, right? Now this time let's determine whether the given situations represents ordinary annuity or annuity due. First, the monthly payment for the car loan is 20,000 pesos at the end of each month. So since the payment is made every end of the month, so we can say that this is an ordinary annuity. Next, May's monthly rent for her apartment is 5,000 pesos and is due at the beginning of each month. So since the payment is made every beginning of the month, then we can say that it's an annuity due. Alright, so that's how we determine whether it's a simple annuity or general annuity, or if the situation is an ordinary annuity or annuity due. Now let's understand more about ordinary annuity. So let's start with this example. Find the future value of an ordinary annuity of 5,000 pesos payable quarterly for 1 year if the money is worth 10% compounded quarterly. So the payment interval here is by quarter, so every 3 months, and the term is good for 1 year, and the interest period is compounded quarterly, so it means 10% compounded quarterly. Now we have here 4 periods since this is a quarter, so that would be 0, 1, 2, 3, 4. So the numbers there represents the quarter, the number of quarters. So this would be the first quarter, second, the third, and the fourth quarter. Now, since it's an ordinary annuity, it means that the payment is made every end of the month, or every not month but every end of the quarter. So since this is the first quarter, so payment will be made at the end of the first quarter, which is here, right? And after here, the second quarter, the end of the second quarter is here, so this is the next payment, and the next payment will be here, which is the end of the second quarter, or of the third quarter, I mean, and the last payment will be the end of the fourth quarter. Alright, so that's why from 1 here to 4 is the end of each period. Alright, now since the periodic payment there is 5,000, so you pay every end of the quarter with 5,000. So for the second quarter, 5,000. For the third is 5,000, and lastly is 5,000. Since that's what is annuity, right? We make an equal payments for every period. So since now let's go with the interest. Since the interest there is 10% compounded quarterly. Now why did I write times 0.025 instead of 0.10? Since the 10% there is the interest rate per year, we still have to convert it, or we still have to solve for the quarterly rate. Now how can we find the quarterly rate? We have to divide 10% with 4, since there are 4 periods. So the 10% divided by 4 is 0.025. Now the 0.025 is the quarterly rate that we need to multiply in every period. So that is times 0.025 for the first payment. For the second period, we have to multiply it also with the interest, 0.025, and for the third period, that is times 0.025. And for the last payment, we don't need to get an interest in it, since this is already the last payment, or the last quarter of the last quarter of your term, or this is your last term already. And we don't there is already no quarters followed by this payment, so there is no interest already, right? So how can we solve for the value of the money for the first quarter? Since the 5,000 pesos that you paid here for the first quarter will not really reflect the exact amount of 5,000. Why is it? Because there is still an interest on it in every period. So the 5,000 here, so the amount here for the first quarter is 5,000 times 1.025 to the power of 3. Why is it? Why 1.025? Is because the one there, we still have to add the principal, which is 5,000, right? And I already explained it earlier. So that's why it's 1.025. The question is, why is the exponent 3? It's because we still need to cover the rest of the interest. So since there are still 2 periods that we need an interest, or we need to pay an interest with, so we need to cover it to the first payment. Alright, now for the second is we have 5,000 times 1.025 to the power 2. Why is it? Because there is still 2 interests that still to be covered, right? So that's why we raise it with 2. And the third is 5,000 times 1.025 to the power of 1. So there is only a 0.025 interest that needs to be covered for the second to the last payment in the third period. So that is 5,000 times 1.025 to the power of 1. And for the last payment is 5,000 times 1.025 to the power of 0. Why is it? Because there is no payment that will be made already, that there is no payment that will follow after this payment of 5,000, since it's already the end of the month or the end of the quarter, right? So you just need to pay the periodic payment, which is 5,000. All right, so that's how the annuity works. So we can say that the first payment, or the first payment of your first period, is always greater than the amount or the payment that follows on the following periods, right? So if we try to sum it up, the accumulation for all of these payments in every periods are what we call the future value. So if we try to sum it up, that would be 5,000 times 1.025 to the power of 3 plus 5,000 times 1.025 to the power of 2 plus 5,000 times 1.025 to the power of 1 plus 5,000 times 1.025 to the power of 0. So the sum is 20,762.58 pesos. So if you try to check it, kindly check it in your calculator if it's really 20,762.58 pesos. So it means that the future value of an ordinary annuity with 5,000 pesos payable quarterly for 1 year with 10% interest compounded quarterly is 20,762.58 pesos. Alright, so that's how we find the ordinary annuity. And since, as you can observe, the payment interval is the same with the interest period, so this is a simple ordinary annuity. Alright, so instead of computing the future value of ordinary annuity like this, we can use a formula for the ordinary annuity. So the formula for the simple ordinary annuity, or just an ordinary annuity, is F equals R times 1 plus I to the power of n minus 1 over I. So wherein your F there stands for the future value, and it is the total accumulation of the payments and interest earned. So this is what we've done earlier. So the F is the future value, R is the periodic payment, I is the interest rate per period, where I is equal to J over M. So the J there stands for the interest rate per year, and M is the conversion period. So if it's quarterly, so your M is 4. So N is the total number of conversion periods, wherein it is the product between the time times the conversion period. And we have there the present value, since not all the time you are asked to find the future value. Sometimes you're being asked to find the present value. So the formula for the present is equals R, still R is the periodic payment, times 1 minus 1 plus I to the power of negative n over I. So the I there still stands for the interest rate per period. The n is still the total number of conversion periods. Right, so this is a formula for the future value for the ordinary annuity and for the present value. Alright, so again, the present value is the principal that must be invested today to provide the regular payments of an annuity. Alright, so now let's go with the example. So Eileen and Irene are twins. After graduation, they were able to work as public school teachers. As preparation for their futures, they are thinking for the retirement plan, which as follows. Starting at age 23, Irene deposits 10,000 pesos at the end of each year for 37 years. Starting at age 35, Eileen deposits 20,000 pesos at the end of each year for 25 years. So the question is, who will have the greater amount at retirement if both entities earn 10% interest compounded annually? Alright, so in order to do that, we will use the formula. So let's start with the Iron's plan. First is we identify the given, so the periodic payment there, which is R, is 10,000. Now for the I, which is the interest rate per period, is we divide the interest rate per year with the M. So 0.10 divided by 1, we have 0.10. Now for the N is the product of the M times the time, which is 37 times 1, so we have 37. Now we substitute this to the formula for the future value. So we have F equals R times 1 plus I to the power of n minus 1 over I. Okay. So we substitute this, so we exchange R with 10,000 times 1 plus 0.10 to the power of 37 minus 1 over 0.10. Now, let's try to calculate this in the calculator. So try to solve this in the calculator. Now we have the answer. For the future value, we have 3,300,394.86 pesos. So which means that um, for 37 years, so probably at the age of 60 years old, Irene will have 3,300,394.86 pesos. Alright, so that's already a big amount. Now let's go with Island's plan. So for the periodic payment there is 20,000. I there is J over M, still it's 0.10, and the N there is the MT, which is 25, since the years covered for his investment, or um, she started at the age of 35 years old, so that's why she only had 25 years before she turned 60 years old. Right, so we have T equals 25. Now we subject this to the formula. We have F equals R times 1 plus I to the power of n minus 1 over I. So substitute now. We have 20,000 times 1 plus 0.10 to the power of 25 minus 1 over 0.10. So try to solve this in the calculator. We have the future value is 1,966,941.19 pesos. So it means that at the age of 60, Island will have an amount of 1,966,941.19 pesos. Thus, we can say that Irene will have a greater amount at retirement than Eileen at the age of 60 years old. Alright, so it just also implies that the earlier you will save, the better. So that's how the time is important. Now, since we're done with the ordinary annuity, now this time let's try to understand for the annuity due. So if we try to recall the annuity due is the payment is made at the beginning of the period, right? So we'll be using the same subdivision problem from the ordinary annuity. So the problem there is the time, or the interval period is every 3 months, so that would be quarterly. So that's why we have 4 periods here. So it'll be 1, 2, 3, and 4. So this is the first quarter, the second quarter, third quarter, and the fourth quarter. Now, since the annuity due is every beginning of the month, or every beginning of the period, so that's why we started. So if this is the first quarter, so we will start to pay the first payment here, right? So we started here, and the next payment would be the beginning of the second quarter. So this would be here, and the third payment would be the beginning of your third quarter, and your last payment would be the beginning of the fourth quarter. So from here to here is the beginning of each period. So since the periodic payment is 5,000, so we have here the payment for the first payment would be 5,000, and we have 5,000 for the third, 5,000 again, and the last payment is 5,000. So for the interest, we have 0.025, since still it's compounded 10% interest compounded quarterly, so we divide the 10% with 4, that's why we have 0.025, and so on, same with the other periods. And lastly, since for the last quarter we pay at the beginning of the last quarter, so that's why there's still 3 months left before the term ends, so it means that we still have an interest for it. So unlike with the ordinary annuity, we the last payment there is really the last month of the last quarter, so that's why there is no months or days left already, or there is no days that need to be covered before the term ends. But in this situation, in the annuity due, after the last payment, there's still a month, 3 months left before the term ends. So that's why there's still an interest in it. Okay, so this time we calculate the amount for every period, so that will be 5,000 times 1.025 to the power of 4. For the second, 5,000 times 1.025 to the power of 3. So why is it 3? Because there are 3 interests that need to be covered. So next, 5,000 times 1.025 to the power of 2. And the last payment would be the 5,000 times 1.025 to the power of 1, because there is still an interest here. Right, so you can see here that the first payment is always greater than the following payments in following periods, right? So if we try to add it up, that would be the future value of our annuity due. So let's sum it up. 5,000 times 1.025 to the power of 4 plus 5,000 times 1.025 to the power of 3 plus 5,000 times 1.025 to the power of 2 plus 5,000 times 1.025 to the power of 1. So if you have your calculator with you right now, try to solve this, and we get a result of 21,281.64 pesos. So it means that the future value of our annuity due with 5,000 as a periodic payment is 21,281.64 pesos. Alright, so if we try to compare the annuity due and the ordinary annuity, the greater amount is the annuity due, because there are more interests that need to be covered, right? So now let's have a formula for the simple annuity due. So for the future value, we have F equals R times 1 plus I to the power of n minus 1 over I times 1 plus I, where your F there is the future value and it is the total accumulation of the payments and interest earned. So we have shown earlier that to get a future value, we just simply add the payments together with the interest earned in every period. So the R there is the periodic payment, I is the interest rate per period, where I is equal to J over M. J is the interest rate per year, and M is the conversion period. So N is the total number of conversion periods, and where N is the product of T times M. Okay, so for the present value, we have R times 1 minus 1 plus I to the power of negative N over I times 1 plus I. So where your P there is the present value, and it's the principal that must be invested today to provide the regular payments of an annuity. So if you spot the difference between the formula of the annuity due and the ordinary annuity, the only difference is the 1 plus I there. Since from the last illustration we have earlier, the annuity due has an additional payment, or has an additional interest, I mean, for the last period, right? So that's why we added the formula for the future and the present value with 1 plus I. Let's have an example. So example is Ilya's elder sister saved for his college education by investing 10,000 pesos at the beginning of each year in an education plan that earns 5% per year compounded annually. What is the total amount of investment at the end of 20 years? So the payment is made every end of the year, every beginning of the year, and the interest period is annually. So meaning the interval payment and the interest period are the same. So we can say that this is a simple annuity. Now, since it's the beginning of the year, so which means that this is also an annuity due. So you can say that this is an example of a simple annuity due. So to solve, we have here the given is the periodic payment is 10,000, I is J over M, so we have 0.05 over 1 since it's annually, so our M is still 1. Now N is 1 times 20 since the time there is 20 years. So to solve this, we substitute this to the formula. We have f is a future value equals r times 1 plus I to the power of n minus 1 over I times 1 plus I. Okay, so substitute this here. We have now 10,000 times 1 plus 0.05 to the power of 20 minus 1 over 0.05 times 1 plus 0.05. Okay, so if you have your calculator with you right now, kindly solve this. And the answer is 347,192.52 pesos. So which means that this would be the future value of your simple annuity due. Right, so we can say that the total amount of investment at the end of 20 years is 347,192.52 pesos. Okay. Now, this time, since we're done with the simple annuity, let's talk about now the general annuity. So, we have the formulas for the general annuity. F equals R times 1 plus I to the power of n minus 1 over 1 plus I to the power of b minus 1. So, your F there is your future value, your R is the periodic payment, I is still the interest rate per period, that is the J over M, and N there is the total number of conversion periods, and your B there is new, right? So that is a new variable. So B there stands for P over C. So where your P is the number of months in the payment interval and C is the number of months in compounding period. So for example, your P there is the payment interval is by quarterly, so it means that the number of months within the payment interval is 3 months, since there are 3 months every quarter, right? And your C there is the number of months in compounding period. So for example, it is compounding annually, so that would be 12 months. If it's compounding semi-annually, that would be 6 months. And if it's compounding quarterly, that would be 3 months. All right, so the formula for the present value, we have r times 1 minus 1 plus I to the power of negative n over 1 plus I to the power of p minus 1. So the only difference there is their numerator, right? So that would be easy to memorize or familiarize. Okay, so let's have an example. Find the present value of an ordinary annuity of 2,000 pesos payable annually for 9 years if the money is worth 5% compounded quarterly. Alright, so the payment interval is annually, so it's payable annually, and the interest period is quarterly. So you can see that they are not the same. They are different, so that's why it's a general annuity. So let's try to solve this. So the given is the periodic payment is 2,000, so that is your I there is 0.0125, since we divide the interest rate per year, which is 0.05, with the conversion period, since it's quarterly, so we divide it with 4. Alright, so the n is 4 times 9, since t is 9 years, so that would be 36. Now the p there is p over c, where the p is 12, since it's annually, that would be 12 months, and c is it's quarterly, so we have 3 months for the compounding period. So 12 divided by 3 is equal to 4, so which means that p is 4. So with this, we substitute this to the formula. We have p equals r times 1 minus 1 plus I to the power of negative n over 1 plus I to the power of b minus 1. So this is your present value. Alright, so substitute this. We have p equals 2,000 times 1 minus 1 plus 0.0125 to the power of negative 36 over 1 plus 0.0125 to the power of 4 minus 1. So try to simplify this and solve the value for this using your calculator. So the answer would be p, or the present value, is 14,155.98. So this is your present value for your ordinary annuity, right? So let's have another example. So Abigail invested 25,000 pesos in an account at the end of each year at 4% compounded semi-annually. So find the total amount of her investment at the end of the 15th year. So since the payment is made every end of the year, so it's an ordinary annuity. And the payment interval is every year, and the interval on the interest period is semi-annually. So they are different, which means that this is a general annuity. So thus this problem is an example of a general ordinary annuity. Alright, so let's try to solve this. Now let's define the given first. The periodic payment there is 25,000, so we have R as 25,000. And the I there is the interest rate per period, so we have 0.04 divided by 2 is 0.02. Now for the N, since we have the time there is 15 years, so we multiply it with 2, that would be 30. And the B there is 12 over 6, since the number of months within the payment interval is 12, since it's annually. And since the compounding period is semi-annually, so we have 6 months every compounding period. So that's why our B there is 2. Now we substitute this to the formula, that is F equals R times 1 plus I to the power of N minus 1 over 1 plus I to the power of B minus 1. Okay, so let's substitute this. We have 25,000 times 1 plus 0.02 to the power of 30 minus 1 over 1 plus 0.02 to the power of 2 minus 1. Okay, so now try to use your calculator. The answer is the future value for the general ordinary annuity is 502,080.19 pesos. Now this time let's have general annuity due. So the formula for the annuity due is F equals R times 1 plus I to the power of negative N minus 1 over I times I over 1 plus I to the power of B minus 1 plus I. So where F is the future value still, R is the periodic payment, I is the interest rate per period, and N is the total number of conversions, or to get it, we have the product of M times T. So P there is still the P over C, where P is the number of months in a payment interval, and C is the number of months in compounding period. So this is the formula for the future value, and for the present value, we have R times 1 minus 1 plus I to the power of negative N over I times I over 1 plus I to the power of B minus 1 plus I. So this is the formula for the future value and for the present value. Alright? So if you are asked to find the annuity due, this is just the formula. For example, find the present value of an annuity due of 10,000 pesos payable quarterly for 10 years if money is worth 6% compounded semi-annually. So since the payment is made at the end of the quarter, so since it's annuity due, so we can use the formula for the annuity due. Now let's try to solve this. So for the periodic payment, we have 10,000. I there is 0.03, and is 10 times 2 equals 20, since the T there is 10 years. B is 3 over 6, since the number of months in payment interval is 3, because it's quarterly, and 6 is the semi-annually, so we have 6 months, so that would be 1/2. So let's try to substitute this to the formula. We have P equals R. P there stands for the present value, plus R times 1 minus 1 plus I to the power of negative N over I times I over 1 plus I to the power of P minus 1 plus I. Alright, so we have now 10,000 times 1 minus 1 plus 0.03 to the power of negative 20 divided by 0.03 times 0.03 divided by 1 plus 0.03 to the power of 1 half minus 1 plus 0.03. So try to solve this in your calculator. We get a result of 304,227.87 as the present value. So which means that the present value of the annuity due is 304,327.87 pesos. So that's how we calculate the present value of general annuity due. And also, to compute with the future value, we just use, do the same process, but we use a different formula, which is the formula for the future value for the annuity due. Alright, so that's all for this video, and I hope that you learned, and see you for the next lesson. Alright, goodbye.